cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. Thank you for joining. Mike, good evening. Finally, we see each other face to face. We have been following each other on LinkedIn for a long time. Maybe you introduce yourself first. Thank you.
My name is Michael Sura. People from LinkedIn and other social networks know me very well. I have many followers, engineer, double engineer, always trying to make this world more sustainable and greener, because it's very important to leave our world to our children and grandchildren in better state than is now. And that's why I'm very interested in green transformation. I worked for natural gas transit company for 17 years. We transited natural gas from Ukraine to Western Europe. We transited Russian gas. And that's why export in gases, in energy systems, and in the big energetics, because it used to be a giant company, but sorry, this company ceases to exist because sanction from the European Union, and the European Union banned import Russian natural gas to Europe. And I became expert in case of energetics, gases, as I mentioned before. And I utilized my knowledge regarding hydrogen. Believe it or not, I was involved in research hydrogen some 25 years ago. Because my company was interested in utilizing hydrogen, about its potential. But we found that its fuel war real. So we ceased any research. We found that it's a troublemaker. It's completely different beast compared to natural gas, because many people, especially there in Germany, now they think that the hydrogen is something like new natural gas. It's not true.
Yes.
Because it's different beast. When you compare it to natural gas, it has very poor volumetric energy density, and it makes troubles everywhere. And plus, it's a very strange gas. It's not easy to transport natural hydrogen. Now, because 95% of produced hydrogen globally is not transport. Now it's used on spot or nearby where is produced. There are, some exceptions, because we have 3 or 4 hydrogen pipelines. One is situated in Germany, one is situated in France, and the longest one is situated in America. But it covers probably those 5% when hydrogen is transported.
They're not very long pipelines, right?
Oh my gosh. In USA, this pipeline is 550 kilometers long. It's pretty long. It covers 2 or 3 states from Louisiana to Texas. And plus there is cavern, where stored, not cavern, or salt cavern, where stored green hydrogen. It's operated by Linde, American company, and it used as raw material. It's not used as a fuel material for producing methanol, ammonia, or remove sulfur from oil products. And it's one or 2 exceptions when hydrogen is transported in large quantities. But the 95% is not transported, and our ancestors, our engineers before us, they know why. Because the transport of hydrogen is not easy. It's very energy intensive. When you want to move or transport 1 kilogram of hydrogen, it costs over 100 kilometers. It costs 2 or 3 euros. It's or 350 American dollars here in Europe. Now I know it because I took a part of one of research where client want to know how efficient or economical is transport of hydrogen here. So try imagine 1 kilogram of hydrogen over 100 kilometer cost 2, 3 euros in European Union. Yes. So it's not easy at all. So it's better use hydrogen at the spot where it's produced. There are still exist plans to import hydrogen from long distances, even from Australia to Europe. And it's not very easy. It's a logistic nightmare because losses are very high, energy loss, and plus it's not very economical because finally you bring from 10 kilograms of hydrogen, 1 kilo in Australia, 1 kilogram of hydrogen energy of 1 kilogram of hydrogen to Germany. And plus you have to transit it and distribute to potential users. It's horrible. Hydrogen is horrible, believe me, because it's a very strange gas. I repeat it for second time. It's very strange gas. Many people are not aware that.
Yeah, because you have been involved, you were aware, because I have heard people saying, oh, I'll put solar on my roof. I have water and I'll split and put hydrogen in the gas pipeline and run gas. I said, well, you might as well make gold if you're that simple.
Yeah.
Why go through all
Yes.
the process? So I think the fundamental problem people don't understand that just because it's another gas, it's not the same. It's highly
Yeah.
flammable. And I did not know that you mentioned the transport cost is so high, maybe because you need to make sure pipes are of a different quality. Because natural gas always leaks. It's okay. It's not that dangerous.
Yeah.
So why it's so expensive to transport? Because of the pressure differences?
Because it has very poor volumetric energy density. You need a big volume of vessel or tank to get hydrogen in and transport. Try imagine that the hydrogen trailer full of hydrogen transport 200 kilograms of hydrogen, 200 kilograms. Only big trailer towed by big truck. So that's why if you look and try imagine that the same truck can tow 25,000 diesel and compare 100 kilograms with 25,000 kilograms.
Because
Yeah.
25,000 liter of
If-
diesel, that calorific value will be huge.
Yeah.
And-
It depends on trailer.
Yeah, of course.
Yeah. So try imagine that you can transport hydrogen of 10 megawatt hours in trailer, 10 megawatt hours. But when you transport diesel, it's 250 megawatt hours of diesel. So that's why it's very expensive to transport hydrogen. You can transport or transit hydrogen by pipeline, but you have to build it and construct it. And it's not easy. It's possible. Why not? Several hydrogen pipelines are operated in the world and they are operated with any accidents because we should know it when there is some explosion. And it's possible, but building hydrogen pipeline costs money. It's possible in sparsely populated areas like Australia or America, but it's not very easy to build hydrogen pipeline in Europe, for example. We have many towns, many villages, land is very expensive. And this is the first factor. And that the land costs a fortune here in Europe. And the second factor is that when you move hydrogen via pipeline, it's very energy intensive. Again, it's similar to a situation when you transport hydrogen via truck. So you need 5, 7 times more energy to transport, let's say, 1 megawatt hour of hydrogen compared to 1 megawatt hour of natural gas. 5, 7 times more energy. Natural gas is moved by pipeline using compressors because you have to move gas and there are losses, friction losses and hydraulic losses. So you have to use compressor station to put new energy to move on natural gas. And the compressor station used to build every 150 kilometers. When you build transport natural hydrogen via pipeline, try imagine that you need compressor station every 20 kilometers, not 100, 150, but every 20, 30 kilometers. So you need to build a lot of compression stations, which cost money, and it's not easy. Many people think that it's something like natural gas. It's not. It's completely different gas. It's a completely different properties. And a lot of people is not aware of it. So this is the problem because they lack information. And when they got information, mostly from politicians who are not very good in physics, math, and it's a job of engineers to spread the truth because only engineers understood how we see, and they avoid to transport natural gas. It's when you produce ammonia, it's much better for you from natural gas. It's much better to transport natural gas to get ammonia plant and produce hydrogen steam, imagine in reformation, and get hydrogen and use hydrogen to produce, to synthesize ammonia. In some strange way that somewhere in the middle of nowhere, so steam methane reforming plant, which produce hydrogen, and hydrogen is transported over 200 or 300 kilometers to ammonia plant, where it's run other Bosch process. It's completely nonsense. So that's why every ammonia plant that produces ammonia from natural gas is built close or at the spot where is connection to natural gas pipeline.
Do you then support some project that we hear that they will convert to ammonia and then transport ammonia rather than transporting hydrogen?
Oh my gosh. Okay. I don't support it. Ammonia is transported because ammonia has a high density energy and it's regularly transported. We are really like it's transported by maritime. It's possible. I think that 10% of produced ammonia is transported via ships. So I'm not against transport of ammonia. We have to be very careful because ammonia is a very toxic gas or substance. And this liquid, we have to be careful. But I'm against transport ammonia as hydrogen carrier, which will be used as fuel, because it's crazy. It's ethic vandalism to make hydrogen from ammonia because ammonia is very important chemical for production fertilizers. Now, 85% of ammonia is used for producing fertilizers, and it's very, very useful material, and it will be waste when it's used as a fuel. It will be vandalism.
You say vandalism because it will not be cost efficient, because some argue, not me, some people argue
Yes,
that,
yes.
okay, hydrogen difficult to transport. You have to pressurize. Liquefaction takes a very low temperature, but ammonia can be liquefied very easily, transported
Yes,
to
yes,
ship, and then it can be turned
yes.
into hydrogen quite easily. It may not make sense economics wise, but you are saying that energy vandalism, but can you explain why you think?
Let me see. Okay. Let's talk about green ammonia because it doesn't
Yep.
make sense to produce hydrogen or fossil ammonia and get hydrogen. It doesn't make sense because fossil ammonia has a pretty high carbon footprint. Let's talk about green ammonia. You know, But when you crack green ammonia, you get hydrogen. It's normal process. It's possible to do, but it's energy vandalism because let's say from 1 megawatt hour green energy at input, you get 10% at output. You get 10% of energy. This process has very poor well-to-wheel efficiency. From 1 megawatt hour of energy or green energy during Australia, you get only 10%. So 100 kilowatt hours of energy during Germany. 90% of energy is waste because there was involved producing hydrogen via electrolysis, 60, 70% efficient. And plus, you have to run other post process, which is 70, 80% efficient. And finally, when you have green ammonia, let's say in Germany, you have to crack. You take a high temperature, a lot of energy. You have to crack green ammonia to get green hydrogen. So we can see that there are so many losses in this chain. And finally, we get 10% for 100% the input. So this is why. And plus, we produce only 300 million tons of ammonia globally, 300 million. And try to imagine that we want to replace maritime fuel, which is mostly bunker oil. We will need 3 times more ammonia like we produced in 2025. We will need 600 million tons of ammonia to completely replace bunker oil or diesel, which is used to power global maritime. Crazy. And there is a problem, ethic problem, because when ammonia is used as a fuel, it would miss in production of fertilizers. And when there's lack of fertilizers, it will be reflected in lower yield of agriculture products. So there will be big danger of famine in some countries which can't afford to buy fertilizers because when it's used as fuel, it will be pick up its prices because it's possible that shipping companies would be afford to pay more for ammonia.
Who wants to make food? Yes, yeah.
So there is an ethic problem to use ammonia. I would leave ammonia to produce fertilizers. I would not touch ammonia as a fuel. And plus, ammonia is incredible toxic gas. One breath, of ammonia gas, and you are dead at the spot. So it will be very dangerous for crew, which is on ship, which is powered by ammonia, and it's very misery fuel. Ammonia needs fuel to be burned completely, because it's very misery fuel. It doesn't burn very well. So there is a technical problem and safety problem. And it's not the way to go to use ammonia as fuel. It's vandalism, it's dangerous, and plus there's danger of famine in poor countries. So it's better to avoid this. And plus there's problem with scale. So there are so many problems with using ammonia as fuel. It's crazy idea, completely.
So, Michael, coming back, all these projects that we read about, say, 5 years ago, most of them didn't happen. Maybe the reason is that people wanted to, every time they saw empty land, Australia, Sahara, they wanted to put big solar, convert into hydrogen, pipe it to somewhere else, and then put into through domestic gas reticulation system, which is ridiculous idea, as you are saying. So that's why this thing didn't happen. Then some school of thought was, we make hydrogen, okay, hydrogen transportation is difficult, we'll convert them into ammonia and bring it back and convert it back to hydrogen. Now you are saying that also it's so energy inefficient, it doesn't make sense. And plus ammonia, there is a huge demand for agriculture. It doesn't make sense to use ammonia as a fuel because that will create all sorts of risk of food scarcity, famine, and others. Because, of course, especially in poorer countries, they won't be able to compete with the shipbuilders with the price, right?
And then ship companies, when there's a higher demand, price goes up. Normal.
It's the same argument that the biofuel almost 15 years ago, that you cannot take agricultural land for biofuel because people will be willing to pay more, but then I won't be able to grow my food because the land went to produce fuel, right? The same argument.
Yes, you are completely right. It's the same situation like biofuels.
What about boats? Then you don't have to use any of those four large ships. Why is not happening that run by electric?
Why? Electric ships is a very interesting idea. Like in Europe, we don't produce lithium-ion batteries in large scale. We produce lithium-ion batteries, but here in Europe, but they are produced by South Korean companies, Samsung SDI, LG, and SKON. They are South Korean companies, and plus CATL, in Germany.
China.
And let's say we have several smaller producers of batteries. Now, batteries in Europe are mostly from China. Now, they are imported from China. And batteries in Europe are pretty expensive when you compare the price of batteries in China. So some ships, it's possible, but it's not very cheap. And plus, you can't use any lithium-ion batteries for powering ship. You have two special batteries, and you need to use specially battery pack, because there is danger of fire. So this is pretty expensive when you need more safety, much more safety. Battery pack is used in ships like for powering cars, and it makes it more expensive. So I think that the price is limited to more spread of battery powered ships. And plus, there is problem because, sorry to say, but the batteries still have a very pretty low gravimetric energy density when you compare it with diesel or bunker oil. So you need to use many tons of batteries to replace diesel or nuclear oil. Okay, so you need several hundred tons of batteries to use to power ship, which covers, let's say, 500 kilometers. It's a matter of several hundred liters of diesel, but you need use several hundred kilograms to in form of batteries. So it's not easy at all. And we are talking about ships which cover distance, let's say 300, 500 kilometers. But when you want to build a ship, battery electric ship, which covers distance several thousand kilometers, you will need a lot of batteries. It will be a huge battery pack, and it's not possible to construct something like that using contemporary batteries. So we need waiting for batteries which much higher energy density, like today's standard 300 watt hour per kilogram. It will be fine when we have batteries, let's say 900 watts per kilogram, which 2 or 3 times higher energy density. So this is a limit for us to use batteries instead of diesel propulsion or bunker oil propulsion system. We have the same limitation in maritime, like in aviation. Batteries are still very heavy for powering ships and eyeliners. We can build ships which would cover 100, 200 kilometers. Yeah, it's possible. It's possible. There are several, maybe 100 ships, battery electric ships, which are operated in China, even though in Norway, I think that 1 or 2 battery ships are operated in Netherlands. So it's not nothing very exotic, but really we need a better price for batteries because from economical point of view, it has very high capex. It has pretty low opex because electricity which power battery electric ship is not very expensive. Expenses regarding fuel, okay, electrons. When it's these are molecules. Okay, so this is main obstacle, very low or relatively low metric energy density and plus price. When we had price like during China, we will see much more battery electric ships which range 100, 200 kilometers. They're in Australia, America, or here in Europe.
Yeah, because exactly as you mentioned, I think 1 liter of diesel is about 9 kWh.
It depends on diesel.
It's close to almost 2.5, 3 kilogram. But when you go to battery, the same 9 kWh needs about 45 to 50 or 60 kilogram, right? So you carry side by side is almost 10 times. So yeah, it's still a long way to go.
Yes, 30 times, 40 times more. But keep in mind that the internal combustion engine has efficiency 30, 40%. But electric motor is 3 times more efficient. So this difference is 10 times because we need 10 times of fuel to match diesel. So we need batteries with higher energy density, definitely. Battery scientists, they work very hard, but it's not easy to achieve such a very high energy density because there are a lot of limits and develop such materials. It's really a problem. If it's not problem, we have such batteries and problem is solved.
Yeah, for the maritime also issue, right? If you are sailing from Australia to somewhere, because we are a remote island, you have to travel all the way. There's no option for refueling. So you have to carry all that oil plus contingency. And when you go for, say, electric ship equivalent, theoretically, you can set up a floating solar charging station in between so that you can have a smaller battery rather than have a super long haul battery, no? So because solar is so cheap, floating solar, large scale, and it doesn't need any fueling. It just need a capacity payment once, capital payment. No?
But let me see, when you travel by ship from Hamburg to New York, there is no island.
No, I'm saying you can do technically floating or whatever. I'm sure you can create a mini Hawaii in the middle.
Yes, it's possible. It's possible.
Artificial Hawaii.
Yeah, it's possible. It's possible. Why not? But we have to wait for better batteries. That's it. And we can manage to build some ships with existing batteries. It's no problem. But It has to be supported somehow, which is not, because those ships are zero emission ships, but it's not very supported as I read, because it's something very exotic for politicians. And it's a problem. It's a really problem. Otherwise, we will see much more ships.
So you are
Okay.
suggesting that going forward, we will see the hydrogen story slowly dampens because not many investments are happening, and the reason being science, that things are not possible and people are making this thing up because they don't understand. So we would see less misinformation and disinformation going forward, I hope.
Yeah. Yeah, I hope, I'm trying to spread the truth about hydrogen. I will be more than happy when fossil hydrogen is replaced by green hydrogen, because we have to decarbonize ammonia, methanol, and then steel making, cement making.
Cement making is a big one, cement making, yes.
Yes, I will not try now to decarbonize cement making. It costs a lot of money and it makes cement more expensive. Even steel making is very expensive when you want to decarbonize. When you want to produce iron ore using green hydrogen, such a steel is 3, 4, 5 times more expensive than fossil steel. We are talking about primary steel, not virgin steel, because recycled steel is something different. When you want to produce virgin or primary steel in the green hydrogen, it depends on price of green hydrogen, but it's very expensive. And there's an idea to decarbonize steelmaking in Germany, and they would like to import green hydrogen from somewhere, from Oman, Morocco, Australia, and make steel, the green steel there in Germany. They have idea to import hydrogen, green hydrogen in liquid state, or as a part of ammonia, or as a part of green methanol. But as I told you several minutes ago, well-to-wheel efficiency of this process is very poor. It's wasting of green energy. And it's much better to produce green steel there in Australia, somewhere very close to electrolyzer side, and export green steel to Germany. It makes much more sense, because exporting or transporting steel, it's not a very energy intensive process. So it's the same is with green methanol, with green ammonia. So green hydrogen is a big opportunity for countries which are rich on renewables, and like they have renewables with a very high capacity factor. You have countries where wind blows day and night, like in southern Chile or Australia or Morocco, and you have countries plus their sun shining 10 hours a day. And those countries are blessed because they have very high capacity of renewables. It's very important because you can produce relatively cheap hydrogen when you use renewables with very high capacity factor. I wrote LinkedIn post, and if you are curious, you can read it. I explained there everything. Germany has renewables with very poor capacity factor. Capacity factor of PV solar in Germany is 10%. When you go to Australia or Morocco, it's close to 30%, 3 times higher. in Germany has capacity factor 15, 20, 25%. On when you go to Patagonia in Chile, capacity factor of wind is 50, 60%. And when you need to produce cheap hydrogen, you need combination of solar and wind. You need combination. You need combine everything to feed electrolyzer.
Yeah, to increase the combined capacity factor at a much higher number.
Yes, exactly. It's not enough when you have a PV solar plant and you need to produce hydrogen, because you will produce hydrogen only when the sun is shining. There is no production of electricity. And you can use a trick, and you can use battery energy storage system. So you can operate hydrogen during night when you feed electrolyzer from battery electric storage system. But it's pretty expensive.
It is expensive. It's almost like someone mentioned that you can burn $100 to generate electricity, but it doesn't make sense.
But it's possible. I'm an engineer, so.
So, Michael, what else you do when you're not thinking about solving climate change? What else you do for?
Oh my God, it's difficult to say. What the hell? I promote the cheapest possible way how to reduce carbon emissions. So I propose to invest money where effect is visible, easily visible. So it's better to decarbonize, let's say, land transport than decarbonize aviation. Because when you want to decarbonize aviation, it costs huge money. So it's better to looking for low-hanging fruit.
Yeah, it's like that. I think McKinsey first published, and then everybody, the marginal abatement curve, right? You can see how much it costs to reduce 1 ton, a different technology.
Yeah, exactly, exactly. So it's better to go this way. It's better don't touch the carbonizer cement production, because it'll cost huge money, and it's necessary to make priority what is possible to decarbonize, spending as little money as possible, because effect will be the same.
Yeah. But if you avoid 1 kilogram of CO2, doesn't matter where it came from, right?
Yes, exactly. And this is very important, because what I can see, everybody wants to decarbonize everything, and it's not possible, because we have some budget and we can afford to decarbonize everything. Because some people think that it's possible to decarbonize everything. Yes, it's possible, but it will cost huge money, and money is very tight in this war. So, and it's better. We have to be very responsible as people, because we waste food, we waste, clothes, shoes, everything. We consume too much. It's better to consume less. It's not very good for economy when you consume less, because our economy needs us to consume. It's crazy, because we consume, so many shops exist and so many people. When we consume less, there will be few shops and people will lose job. So it's not good, but they consume too much, and it's not good for our planet. And we should try to reduce CO2 emissions this way. We have to be smart, I think. It's my opinion. I'm engineer. I'm not economist. I think that I'm good in economy. I would leave it for economists who are better expert than me. I'm engineer. I'm trying to find solution, how to do.
That's good. Thank you so much for your time. Is there anything else you want to share, Michael?
Well,
I learned a lot of things from you today.
I would ask people to be more responsible to our children and grandchildren, because we were not very responsible, I think, in the past, because we missed information, because we were not very good informed what's going on. Now we have information, but we still don't reflect them in everyday life. So it's better when we are more responsible. Drive less, walk more, for example. Don't buy so many clothes. Don't buy, be smart when you buy food. Don't throw, no, and live more sustainable life. This is very important. We have to be collectively responsible because we're living on the same planet. And this is cool. I think that the Western people, Australians, Chinese, Japanese, to survive because, as you can see, we have so many disasters in this war. And the border between sustainability and unsustainability is very thin. And we are approaching to this line and try to do everything, don't cross this one, and stay in this sustainable part and not in the unsustainable part. Because when we are there, it will be help for us.
Absolutely. Thank you very much for your time, Michael.
You're very welcome.
Thank you. Thank you. We hope you enjoyed this episode of Energypreneurs. To continue listening to this conversation, please visit us at Energypreneurs. Thank you. See you next time.